Our next lesson is about the formula for the circumference of a circle and the area of a circle. And this will go along with Module 3, Lesson 4 in Engage New York. But I wasn't really happy with the materials that are in your student materials, and so I'll largely do this without using the Engage New York materials. If you want to take notes, and you should, write those down on the blank page to the left of Lesson 4. In this lesson, we'll hit one CCRSM standard, and that is GMD1, to give an informal argument for the formulas for the circumference of a circle and the area of a circle. I'm going to start with the circumference of a circle. And to me, this argument is based on the definition of pi. Now, I know that you know that pi is roughly 3.14, and it goes on forever. But the definition of pi is that pi is equal to the ratio between the circumference and the diameter. Meaning, if I have a circle here, and this is the diameter, and I took that diameter out and began to stretch it around the outside of the circle, I'd have 1, 2, 3, and a little more diameters that will fit around the outside of the circle. So roughly 3.14159. It goes on forever. But there's that many diameters that fit around the outside of a circle. Now, if I multiply this equation, both sides by the diameter, to solve for the circumference, then I find that the circumference is equal to pi times the diameter, which is one of our formulas that we can use to find the circumference of a circle. Now, we often use the radius as well. So the radius is the distance from the center out to the edge of a circle. And each diameter is 2 radii, because you can go either direction from the center. And so if I plug that in, then I find the circumference is equal to pi times the diameter, which is 2 times the radius. Now, the way we write terms is in order from simplest to most complicated. And so you could write pi to r, but that's not in the order of simplest to most complicated. The simplest term here is 2, and so we typically write 2. And then the next most complicated is pi, and r is the most complicated because it's a variable. And so 2 pi r is the other formula we have for the circumference of a circle. Okay, well, that's the first part of this standard, to give an informal argument for the formula for the circumference of a circle. Now, to find the area of a circle, I'm going to go to an applet that was developed on GeoGebra. Here's an applet I found online that really clearly demonstrates how to find the area of a circle. Now, giving credit where credit is due, this was developed by Anthony from the GeoGebra Institute of Hong Kong. So thank you, Anthony, for making this amazing applet. First, we have the area of a circle. Well, we have the circumference. And if I take that circumference and I straighten the circumference, then I get that length. Okay? Let me remind you that we just talked about the fact that the circumference is equal to 2 pi r. That's pretty important. That'll come up later. So if I take that circumference and straighten it out, I will now cut this circle into different parts. Okay, I will dissect it, and right now it's in 12 parts. Now, each of those shapes is not a triangle. It's called a sector. And we'll talk more about sectors in Module 5 at the very end of the year. Okay, now I can rearrange these and put them all in a straight line. I think it looks really cool. In a straight line. But then I will take half of them and put them on the other half, and I get that shape. Okay? Now, it looks roughly like a parallelogram. Okay? And we know how to find the area of a parallelogram. Okay? It is base times height. So the area equals base times height. Now the base down here, this base is half of the circumference. So if you go back and look, just the red part is half of the circumference. Okay? Now half of the circumference is just pi times the radius. And this height right here, this length, the height of this parallelogram is the exact same as the radius. And so the area is pi times the radius squared, which maybe you already know, but this is an informal argument for where that came from. Okay, now, if you're saying, whoa, 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 Mr. Lewis, it's not exactly a parallelogram, that there are some bumps here. The way we manage that is that we cut it into smaller pieces. Okay, so if instead of having 12 pieces, if I cut it into, let's say, 30 pieces, okay, do the exact same thing, it will look even more like a parallelogram. If we cut it into, let's say, 100 parts, it will look even more like a parallelogram. Looks more like a rectangle. It's getting closer to. This goes up to 200 parts, which you can barely even see. If you do the exact same thing with that, it looks very close to a rectangle or a parallelogram. But still, you get base times height, and the base is half the circumference, pi times the radius. The height will be the radius, and so you get the area is pi times radius squared. Now, I'm not sure what to write down in your notes for this. It's a very visual thing. Without this diagram, it'd be kind of hard to draw the picture. But that's how you find the area of a circle. And that's it. So this video was about the formula for the circumference of a circle and the area of a circle. Thank you for watching.